Hello everyone, welcome to my civil engineering YouTube channel. Please subscribe to the channel and hit the bell icon to get notified when I post my new videos. Today I'll be discussing how to analyze shear force and bending moment for a simply supported beam when it is subjected to concentrated load. So here I have a numerical here wherein AB is a simply supported beam which is subjected to the concentrated load of 4, 10 and 7 kilonewton magnitude at the points E, D and C. So wherein E is at the distance of 1.5 meter from A, D is at the distance of 2.5 meter from point E. So C is at the distance of 2 meter from point D. So before analyzing the shear force and bending moment for the given beam, so we are supposed to first and foremost thing is we are supposed to find out what are the support reactions at A and B. So for finding the support reaction, we are going to implement the equilibrium conditions for the given beam here. So the first and foremost equilibrium condition is that summation of all the horizontal forces in the beam is equal to 0. That is, algebraic sum of all the horizontal forces is equal to 0. So here, whenever in this beam, we can notice that there is no horizontal forces which are there in this beam. So therefore, the first equilibrium condition is automatically satisfied. So second equilibrium condition is that summation of all the vertical forces is equal to 0. So in this equilibrium condition, so we are just applying the sign convention that upward forces are taken as positive and downward forces are taken as negative. So with this sign convention, if I just proceed for the solving for the second equilibrium condition, so let me consider the reaction at A as RA, the reaction at B as RB. So with this, if I just calculate, RA and RB are the two forces which are going in the upward direction. So I just take summation of all the upward forces as equal to downward forces. So therefore, there are three downward forces which are there, that is 4, 10 and 7 kilonewton here. So therefore, RA plus RB is equal to 4 plus 10 plus 7. That if I just add up, so I'll get RA plus RB as 21 kilonewton. So RA plus RB as 21 kilonewton. So next equilibrium condition is that summation of all the summation of all the algebraic sum of all the moments about a point is equal to 0. So you can just take either point A or point B as a reference point for calculation of the moments. So here I am going to take A as my reference point. So after taking the reference point, after taking the moment at A as reference point, so we are going to find what is the moment and we are going to equate that to 0. So starting from point B, so force into perpendicular distance. So starting from point B, RB into this distance, RB into this distance. So force into perpendicular distance. So I am going from right hand side. So as per my sign convention, right hand side anti-clockwise moment is taken as positive and clockwise moments are taken as negative. From right hand side, anti-clockwise moments are taken as positive and clockwise moments are taken as negative. So RB into 8. So RB into 8, it is an anti-clockwise moment, hence it is taken as positive. So next is 7 into the distance between C to A, that is 6 meters. So 7 into 6, it is clockwise direction. So go along the force through the line of action. So it is right side clockwise moment, it is taken as negative. So next is 10 into 4. So 10 into 4, it is a clockwise moment. So I am going from right hand side. So as per my sign convention, right hand side force with a clockwise moment is taken as negative. So next is 4 kilonewton with a distance of 1.5 meter perpendicular distance. So 4 into 1.5. So since it is right hand side, so it is a clockwise movement. So right hand side clockwise movement, again it is considered to be as negative. So if I just solve this, I will get the value of RB as 11 kilonewton. And if I put that RB value in the sigma V equation, I'll get the value of RA as 10 kilonewton. So this is how to find the support reaction with reference to the equilibrium conditions. So next step is calculation of shear force. So first point, I'm going to start from point B, that is from right hand side. So as per my sign convention, right hand side upward force is considered to be as negative and downward force is considered to be as positive. So with this sign, and the same will be with the vice versa case for the left hand side forces. So I just consider from point B. So point B, the shear force at point B, we are going to take the force at that point plus the force at previous point. So since point B is the initial point, so we don't have any points previous to point B. So therefore, the shear force at point B is nothing but the reaction RB. So therefore, it is acting in the upward direction. So hence it is taken as negative minus 11 kilonewton. So it is minus 11 kilonewton. Next is point C point. So at C point, shear force at C point is nothing but force at that point plus the previous point, that is previous to a point C we have only B point which is having the reaction of 11 kilonewton. So right side upward force is considered to be as negative and downward force is considered to be as positive. So at point C we have 7 kilonewton force in the downward direction, hence it is considered to be as positive, and 11 kilonewton we have force in downward direction, hence it is considered to be as negative. So therefore it is minus 11 plus 7, it is minus 4 kilonewton. So next is at point D. So at point D we have previous to the point D we have 2 points, that is point C and point B. So the shear force at point B is at that point shear force plus the force acting at the previous to the point, that is at point C and point B. So here it is minus 11 plus 7 plus 10. Why it is plus 7 plus 10? Because it is acting in downward direction, and 11 is it is acting in upward direction. So if I just add up, I'll get the magnitude as plus 6 kilonewton. So next is point E. So here previous to the point E I have 3 points, D, C and B. So at D and C we have 10 and 7 kilonewton force which is acting in downward direction, and at B we have 11 kilonewton of force which is acting in upward direction. So it is minus 11 plus 7 plus 10, and also we are supposed to consider the force acting at the point of reference also. So therefore I am going to consider 4 which is acting in downward direction, hence it is positive. So minus 7 plus 7 plus 10 plus 4. So if I just add up, I'll get the magnitude as 10 kilonewton. So next is shear force at E point. Shear force at E point is nothing but the reaction at A point. So therefore the reaction at A point is equal to 10 kilonewton itself. So next is calculation of bending moment. So while calculating the bending moment, we are supposed to consider only the previous point from the reference point. We are not supposed to consider the force acting exactly on the reference point. Why? Because moment is nothing but force into perpendicular distance. So if I just consider the force which is acting exactly on the reference point, then the perpendicular to distance from the reference to the reference point will be equal to 0. So therefore the moment exactly acting with the force with reference to the reference point will be equal to 0 itself. So therefore bending moment acting at point B is equal to 0, because At point B there is no previous point, so therefore bending moment at point B is equal to 0. So next is point C here. So previous to point C we have one point, that is point B. So therefore we are supposed to consider the force acting at point B only. So therefore force into this distance, so force acting it as RB. The perpendicular distance between B and C is 2 meters. So therefore it is RB into the distance. So RB here acting is so RB here acting is 4 kilonewton. RB here acting is 11 kilonewton. So perpendicular distance is 2 meters. So 11 into 2. So here it is acting in the anti-clockwise direction. So right side anti-clockwise force is considered to be as positive. So it is 22 kilonewton meter. So next is point D. So previous to the point D we have 2 points, that is point C and point B. So starting from point B, so it is RB into the perpendicular distance between B to D, it is 4 meters. So 11 into 4, it is acting in anti-clockwise, hence it is taken as positive. So the next point is point C, which is with the 7 kilonewton of force. So 7 into perpendicular distance between C and B is 2 meters. So 7 into 2, which is acting in clockwise. So therefore it is considered to be as negative. So 11 into 4 minus 7 into 2, it comes on to be plus 30 kilonewton meter. So the next is point E. So we have previous to point E we have 3 points, B, C and D. So starting from point B, that is 11 into 6.5, that is distance between B to E. So next is 7 into 4.5. So since it is clockwise, it is considered to be as negative. 10 into 2.5 clockwise, hence it is negative. So if I just solve that, I'll get the magnitude as 15 kilonewton meter. Similarly, the bending moment at point A. So previous to the point A, I have 4 points B, C, D, E. So which is having the magnitude of RB 7, 10 and 4 kilonewton respectively. So if I just take the moments exactly at point A, it must and should be equal to 0. So if I just solve it, I am getting the value as 0. So next is drawing the shear force and bending moment. So I just draw the shear force diagram by drawing the baseline first. So this is the baseline. So upward forces are drawn above the baseline and downward forces are drawn below the baseline. So here first and foremost thing, I have got the value at B as minus 11. So next is minus 4, I have got it. So plus 6, plus 10 and plus 10. So here since it is the point load, the shear force variation is stepped variation. So hence it is shown in the stepped variation. So next is the bending moment diagram. So I just draw the baseline here. So upward, so positive values are plotted above the baseline and negative below the baseline. So at B it is exactly equal to 0. Hence it is exactly drawn on the baseline itself. So exactly at point E I have got it as plus 22 kilonewton meter, and at point D I have got it as plus 30, and exactly at point E as 15 and A as 0. So therefore the variation here is linear. The bending moment variation for point load is linear. So therefore it is joined by a straight line. So this is all about the shear force and bending moment analysis for the simply supported beam when it is subjected to the concentrated load. Thank you for watching. Please like, share and subscribe the video. Thank you.